Friends, in this video we are going to discuss the numerical problem number 14th from chapter 3 of Nootan ISC Physics. The question says that 10 joule of work is required to move a charge of minus 200 coulomb from point A to point B. Which of the 2 points is at a higher potential? What is the potential difference between these 2 points? And if the points are 4 cm apart, what is the component of electric field parallel to the line joining A and B? Friends, this particular numerical problem is of fundamental importance to us. So please take care about this particular numerical. It helps us to understand many fundamental points that we have discussed in our theory class. If you haven't watched that particular video on electric potential and potential energy and properties of electric potential and potential energy, I would highly recommend you to go and first watch that video and then come back to this particular problem, friends. From our discussion in the topic of properties of electric potential, I told you that a free positive charge always move from a region of higher potential to a region of lower potential. So if I leave a positive charge over here, this is some positive charge, so this positive charge will move from a region of higher potential A and B. So it will move from a region of higher potential to a region of lower potential. Now to the contrary, if I leave a negative charge, suppose I've got a negative charge, then this negative charge would move from region of lower potential to a region of higher potential. So friend, one should know at this juncture of time that a free positive charge always moves from region of higher potential to a region of lower potential. And to the contrary, if a free negative charge is placed, it moves from region of lower potential to a region of higher potential. That suggests, friends, that in both the cases you don't have to do the work. Thus, in both the above cases, you don't do any work, rather work is obtained. I hope this point is clear to all of you. Work is obtained whenever charge moves from, if it is a positive charge, it should move from a higher potential to a lower potential, and if it is a negative charge, then the work will be obtained if it moves from a lower potential to a higher potential. So in what situation you do the work? So work is done. When work is going to be done? Work is done whenever I move a charge, whenever we move a positive charge from lower potential to higher potential. And in case of negative charge, from higher potential to lower potential, friends. Now that is what is the crux of the problem, from higher potential to lower potential. So if you know this basic property, friends, then only this question makes sense to you. So work is going to be done whenever I am going to move a negative charge from a region of higher potential to a region of lower potential. Now if you look to this particular problem, they say that 10 joule of work is required. That means work is done in moving a negative charge from point A to point B. So now the question is, when the work is going to be done in moving a negative charge? The work will always be done in moving a negative charge from a region of higher potential, from a region of higher potential to a region of lower potential. So if I draw, or if I take these 2 points A and B, let me mark this point as A and let me mark this point as B. So work will be done whenever I am going to move a charge, a negative charge. A negative charge is there. So whenever the work is done in moving the negative charge from a region of higher potential. So this becomes my higher potential, friends, and whereas this becomes my lower potential. So this is my lower potential, this is my higher potential. So the question asks me, which of the 2 points is at a higher potential? You know the answer. Point A happens to be the point of higher potential, friends. Is this point clear to all of you? This is a very interesting, very important question, beta, that is going to be understood by you all if you are understanding the concept of electric potential. Now let's move on to the second part of the problem, friends. The second part of the problem says we need to find out the potential difference between these 2 points. Now friends, you already know that the work done is always equals to Q0 times PD. So in electrostatics, I would like you all to remember that work done formula is Q0 times potential difference, friends. So this is the formula for work done in electrostatics, and I would like you all to just keep this fact into your mind, beta. Now we already know A is at a higher potential and B is at a lower potential. So work done, how much work you are doing? We are doing 10 joule of work. Now what is Q0? Q0 is the magnitude of the charge that you are moving. Now remember, friends, I'm again and again repeating one thing, that all the formulas that have been given in electrostatics, the Q in the expression only stands for the term magnitude of charge. It has got nothing to do with the sign of the charge. Please take care. Okay, so work done is 10 joule. Q0 happens to be the magnitude of charge. What is the magnitude of the charge? It is 200 coulomb. I'm not interested into the sign of the charge, so it's just 200 coulomb. And then I'm looking for the potential difference. What potential difference? Potential difference is VA minus VB. Okay, this is the potential difference, VA minus VB, I'm looking for. So VA minus VB, or simply I am going to call it as PD, that is stands for potential difference, will be equals to 10 upon 200, friends. So that makes it 0.5 into 10 to the power of minus 1, or simply 0.05 volt, friends. So that is the potential difference between the points A and B, A being at higher, B being at lower. So VA minus VB, and I'm going to call that as a potential difference, friends. Now the third part of the question says to find out the component of the electric field if the distance between these 2 points happens to be 4 centimeter apart. Now remember, friends, I also told you electric field is negative gradient of potential difference, haven't I? One of the properties. Once again, if you haven't watched all those videos, please kindly go and first watch them. They are the concept building blocks, friends. I told you electric field is equals to negative gradient of potential. Negative gradient of potential. Now the minus sign indicates only one fact. What is that fact? It tells me that along the direction of electric field, potential always decreases. The negative sign is for that. Potential decreases in the direction of electric field. Potential decreases in the direction of electric field. Decreases in the direction of electric field, friends. So if I am just interested in the magnitude part, so I can say the electric field is equals to delta V by magnitude of delta V by delta X. Now what is delta V in this expression? Delta V stands for potential difference. What is delta X? Distance between those 2 points. So the question asks me to find out the electric field. So electric field will be, E will be, what is the potential difference between those 2 points? That happens to be 0.05 volt. And what is the distance of separation between those 2 points? That happens to be 4 centimeter. So that becomes 5 by 4 into 10 to the power of 4 centimeter into 10 to the power of minus 2. So minus 2 goes on the top, it becomes plus 2, and there is minus 2 already there. So minus 2 and plus 2, so that cancels out each other. So I am left with 1.25 volt per meter. I hope this explains how the things have been solved. Please take care about this particular numerical problem. As I just now told you, this is a very fundamental level of numerical problem, which at class 10+2 level you should always know. It extrapolates especially the points or the properties of electric potential that you have learned in our theory classes, friends. Thank you. Friends, thank you for watching. Don't forget to give a like or comment. अगर अभी तक आपने मेरे इस चैनल को सब्सक्राइब नहीं किया है तो प्लीज डू द सेम. Don't forget to hit the bell icon so that whenever a new video is loaded you get the notification. Take care and we will meet back again with a new video and a new solution. Thank you, friends.